Hi girls. Let me start my new lesson. So in the first three lessons in this chapter, we discussed about polynomials and we learned how to add, subtract, and multiply polynomials. So that's what we did in the first three lessons. Today, we will continue also multiplying polynomials, but we are going today to multiply a special case, which will make our multiplication easier. Let's see what should we do. Look at this. Sometime we know that if we have a plus b, we know that this is repeating the multiplication, which is a plus b times a plus b, definitely between parentheses, and deal with this one. It is like one thing. We learned in the previous lesson, after we distribute, when we multiply binomials, we get this result. Finally, once we add, since we can change the order for these, when we add them, we will get this one. Today, we will have a rule will help us to get from this one directly into this one. How can we do that? Let's move. So our key concept tells us if we have a plus b all this to the power 2, that means you will take the first number squared, the last number squared, you will put it at the end, 2 plus the first term times the second term. So that's the idea. Same thing if you have minus. As I said before, a plus b all this to power 2, that is not equals to directly a squared plus b squared. So that's not equals to this one. There is something I should put it in the middle, which is this value. So this rule will help me if I have, for example, like this, x plus 4 all this to power 2. So take the first term squared, the last term squared, 2 plus first times second, 2 plus first times second term. This is the idea. Exactly same thing if you have subtraction. This rule work if you have multiplication, if you have addition and subtraction. While keep in your mind, if you have subtraction, the only part that will be negative, only this one. This one will be positive. Why? Because once I squared this number, so any number 1, negative 1 times negative 1, it will be positive 1. So that is negative 1 squared. So since I have squared, which is power, even power, that means for sure I will have positive. That's why this value for this term will be positive. So just memorize it. First term squared, the last term squared, plus 2 times the first term and the second term. Just memorize it like that. So if I'm telling you what is the simpler form of each product, so take the first term squared, the last term squared, which is 8 to the power 2, then 2 times the first times the second, 2 times x times 8. Now I will organize it plus. Now I will organize my work. So that is will be x to the power 2. 2 times 8, it's 16. X plus 8 to the power 2, 64. That's it. Same thing with this one, but here more things I have to do. So 2m minus 3. I'm going to use my rule. The first term squared. So keep in your mind the first term squared. That means all of it squared, not only one from them and then you leave the others. Don't write 2m directly squared. No, don't write like that. Then you will continue. The last term squared, which is 3 to the power 2, minus 2 times the first term times the second term. So just multiply them like that. 2 times 3. That's according to the rule that I learned. Let me work on that. We learned in the previous chapter, if we have multiplication here, we can distribute the power. So 2 to the power 2, it's 4m to the power 2 minus 2 times 2 times 3, 2 times 2, 4, 4 times 3, 12. So that is 12m plus 9. This is the idea. The idea is very simple. Let me solve with you this one. So the first number squared, or the first term squared. I always write the last number like this, directly. Squared 2 times first number, because I have minus, I will put my minus here. 2n times 7. So that is will be times n times 7. So that is will be plus. So n squared minus 14n plus 49. Same thing with this one, which is exactly the same idea that I did before. 2x all this to power 2. The last term, 9 to the power 2. The first term squared, the last term squared, plus 2 times the first times the second one. So it's like you need to memorize it like a song. So 2 times 2x times 9 plus, so that is will be 4x to the power plus 4, 2 times 2, 4, 4 times 9, 36, so that is 36x plus 81. So it's really easy to calculate. I'm going to give you one more exercise to make sure that you are okay with the idea. I'm going to solve this one, and I'm going to solve this one. So for this one, 5m squared, all the squared, minus this minus, I will do 2 times first term times the second term plus 2 to the power 2, which is the last term squared. So that is will be 5 to the power 2, 25 m squared minus 2 times 5, 10, 10 times 2, 20. So that is the 20 m plus 4. This is the idea. I'm going to do with you the other one. This one squared. Since I have minus, the minus will be here according to the rule. 2 times the first times the second. So 2 times 11, it will be 22. 22k plus 11 to the power 2 will give you 121. So 11 to the power 2, which is 11 to the power 2, which is will give you 121. So that is 121. So that is exactly the same idea. Let's move to this one. Apply squares of binomials. I need what here? Square outdoor patio is surrounded by a park walkway as shown here, this one. What is the area of the walkway? I need to find this one. In this chapter, they repeated the idea many times, if you notice. So what will I gonna do? I will find the area for the big one, for all, and I will minus from this one, the area for this part, the one that inside, which is the area of patio. So that's what should you do. Let's find the total area for all this big square. So what is the area for this square? Let's directly say the area of the walkway, the area of, I will write W, which means the area for the walkway, which is equals to the area, the total area, I will write T minus the area for the patio. I know the area for the squared, it's given by this big squared, which is side square. I will take this one, what I have here, I will square this. So that is x plus 6, all this, the power 2. You can say x plus 6 times x plus 6. You can say that. No problem if you say that. Then you need to multiply them. But I wrote like this because I want to use the rule that I just showed you. Then we need to find the area for the small x times x, which is x squared. I learned what to do with this one in the previous problem. So that is x squared, the last one squared, which is 36, 2 times x times 6, which will be 12, x plus 36, drop this one, minus x squared. Now you just need to work on that and see if you have like terms. This one and this one, they are like terms, but that's 1 minus 1, so these are opposites, so just you can cancel them. So what is the remaining? What is the area of the walkway? So what is the area of that? That's a plus because here plus. So that will be 12x plus 36. Done. So the area of the walkway is this one. The idea is really simple. So let's move to got it. Let's check our understanding. Suppose the brick walkway is 4. So here we have they change only little thing, which is 4. So what should we do if we have the walkway is 4? So that will be if we have exactly same thing. But the only change is this part, which is here. This is 4 instead of 3. While the others exactly same thing. I will leave this, I will give you instead of this one, I will give one from these and then I will go back to this one because I want to give you something more clear. Let's do this one. So exactly same thing, I want to find the shaded region. Since I need to find the shaded region, I'm going to do exactly same thing. I will find the area for the big one, for the big square, so the area for the large square minus the area for the small square will give me the area for the shaded region, for the region that I need. So the area for the large square, it is x plus 4 all this to the power 2. Why I'm doing that? Because I have this square and the area for the square is side square. You will take a side, you will multiply it by itself 2 times. Minus. What is the area for the small square? It is x minus 1 all the square. Here you need to focus because there is a crazy negative sign here. You have to focus on that because all the terms inside should be multiplied by -1. So this will change a lot of things. So that will be x to the power 2 plus the first term squared, the last term squared, then 2 plus the first times the second. So that will be 8x plus 16 minus, what will I have here? I will keep my parentheses. Please be careful for this point. If you have something like that, that means this negative for all the terms that you have inside. So x squared minus, because I have minus here, 2 times the first times the second, so which will be 2x plus x squared, 1 squared, which is 1. So that is 1. Now I will distribute my negative so I can see what will gonna happen. So plus 8x plus 16 minus x squared plus, because minus minus, I'm distributing the negative, 2x minus 1. So that will be, I will see if I can simplify something. Yes, this one and this one will go together. This term with this one, I can simplify them together. So that will be equals to 8x and 2x will be 10x. 16 minus 1, that will be plus 15. So that's the idea from this part. So for the previous one, we need to say if we have let me go back to this one. That's what they gave us here in the previous problem, but they said if this walkway, it was a 3. It was a 3. What about if this one 4? That means they increased this walkway by 4. And it was a 3. That means I need to minus 1 from this side, from this one. So that should be here minus 1. So again, I will tell you again. I have this walkway here around it, which is 3 feet, which is the length for this side is 3 feet. While this one is x, this one is x. What about if I increase this side into 4? If I increase it into 4, that means I will take from this area. So this will be minus 1. I will take from it. I will cut from it 1. So 1, that's a 3, and 1 is 4. That's what we have here. So we need to work on that. So that will be, again, the area of the walkway is equals to the total area minus the area for the patio. So the area, the total area is x plus 6, all this to the power 2, and we just did it, minus, now the patio, will be the change, which will be minus 1, x minus 1 instead of having x. So x minus 1. I hope you understand me why I said this is minus 1. So that will be exactly the same exercise that I did. So that is will be, we just did it, x to the power 2 plus 212x plus 36. For this part, I must keep the minus and I will put my big squared. So that is will be x squared minus 2x. We just did it also, plus 1. So after you distribute, you will get x to the power 2 plus 12x plus 36 minus x squared plus 2x minus 1. So these two terms will be cancelled because these are opposite. 12x and 2x, that will be 14x. We have also 36 minus 1, that will be 35. So that's for this problem. I feel there is something in this problem. I will gonna return back to this problem, but I'm going to continue the rest of the lesson. Now here, I don't want to use this kind of a question, but I will explain for you the idea. Here I'm going to use exactly the same rule that I gave you, but I'm pretty sure since you have calculator, you are not going to use this. But this way will be helpful if you don't have calculator. So you know that you can easily deal with the numbers including 0. I can say 40 minus 1, I can say this is represent 39. 40 minus 1, that's 39 to the power 2. You can easily find that the first term squared, the last term squared, 2 times minus 2 times the first number times the second number. So 2 times 40, it is 80. Here I forgot to write squared. Plus 1. So you can easily know that 40, it's 4 to the power 4. You will put zeros, because you can say easily without calculator 40 times 40, it is, you just will drop your zeros, and then you will say 4 times 4, which is 16. So that is 1,600 minus 80 plus 1. You can easily minus this one to get 1 and plus this one, 1,521. So this is the idea for this problem. Let's see the other one. Let's see this. Here you have two options. You can say 90 minus 5, all this to the power 2. Or you can say, so that is 90 minus 5, or you can say 80 plus 5, all this to the power 2. You will get at the end exactly the same result. Let's do this one. So that is will be 90 to the power 9, to the power 2, sorry. 2 times the first times the second. So 2 times 90 times 5 plus, I will write immediately 25. Keep in your mind here, there will be 2 zeros, 90 times 90. 90 times 90, it is 8,100 minus 2 times 5, 10, 5 times 90, 5 times 9, 10 times 9, 90, so that is 900 plus 25. You can just easily add these. Once you add them, that will be 9,000. 9,000 plus 25, so that is 9,025. While this one, we will get exactly the same result. Look at this. So 80 to the power 2, I will directly do it. That will be 6400. 2 times 5 times 80 plus 2 times the first term and the second term. So that is will be 800 plus 25. Once you add this one with the others, you will get exactly the same as this result. So once you, since here you have to, oh, here I added them. Here you need to minus. So for the first one, you have 8,100 minus 9,000 minus 900 plus 25, which is will give you 7,000. That is 7,000. 22,5. Same thing with this one. If you add them all together, if you add 6,400 plus 800 plus 800 plus 25, you will get exactly the same result, which is 7,022.5. So this is the idea. Is there more than one way for 85? Use mental math, which is yes, you will say yes. And this is the other way that I already gave you here. So this is, I feel this is not much useful, but I just gave you just to show you how we deal with the rule that I just showed you in the key concept, which is the property. For that, I'm not going to do more or relate more or extra exercise. Let's see this one. If we have A plus B exactly the same as this one here, B and B here, but you have different sign here, opposite sign. Once you work on that and start distributing and use the same way, you will get this one. So this rule will tell you if you have one positive and in the other parenthesis negative, and the first term exactly the same as the first term and the second binomial, which is also the second exactly the same as the second, you will directly take the first squared minus the last squared. So look at this. This exactly the same as this one. The only difference is the sign. So directly we'll take first squared minus second squared. Let me show you. Please don't confuse between the first one and the second one. So let's do this one. The first one exactly the same as this one. This one exactly the same as this one. The only difference is in these. Since I have these are opposite, I will gonna say, okay, the first one squared minus the last one squared. The first one squared will give me x to the power 6 minus 64. Done. It is much easier than multiply first by second, first by the last, and then same thing with the other side. Since this is special case, as we said in the beginning, because this is special case, this is a special case. I don't have a different, I have exactly the same thing, but the only difference is the sign. So keep this in your mind. Look at this, here exactly same idea. So that is will be x to the power 2 plus minus 9, sorry, to the power 2 according to the rule. So that is will be x to the power 2 minus 81. Here, exactly the same idea. 36 minus the minus from the rule, directly you will say minus m to the power 2, all this to the power 2. Please don't forget that. Not because he's here power 2, you will directly say it's this is the power 2 is already here. No. So 36 minus m to the power 4. This one. This exactly the same as this term. This term exactly the same, but we have them opposite. So I'm going to say 3c, all this to the power 2, minus, from my new rule, 4 to the power 2. So that is will be 3 to the power 2, c, 2 minus 16. So that is will be 9c2 minus 16. This is the idea. Let me give you one more exercise. I just want to write for you a very important note. What is the difference if I say here, if I change this one into minus? Note. X plus 9, if I change the other one into x plus 9. Since these are same exactly, same sign, so that is will be x to the power 2, that will be x plus 9, all this to the power 2. So I'm going to return back to my first case, which is my first property. That will be x to the power 2, the last one to the power 2, plus 2 times first times second. Keep in your mind the difference between this one and this one. So this one and this one is different. Also, keep in your mind if you have something totally different like this, plus 9, for example, x plus, let's say, 4. Here and here we cannot use them. If I have this, I'm going to use the exactly same thing that I did in the previous lesson. First by first, second by second, the old and the regular way. If I have exactly same thing but different in the sign that I'm in the middle. So in this case, I will do this way. Directly, I will say the first squared minus the last squared directly. If I have them exactly same, which means this is a repeat the multiplication, which means it's a power 2. So that is will be exactly the same rule that I gave you today, first property. Let me solve with you one more exercise to make sure that you understand the idea. I have this one exactly the same as this one. The only difference is this. So I'm going to say that is x to the power 2 minus 9 to the 3 to the power 2, which is 9. I'm done. So that's the idea. Here is same thing. It is 100 minus y to the power 2, and so on. Here is exactly same idea with mental math. Again, I'm not just using this a lot, and just I'm give it to you in case if you have something like this in Pearson. So you can, or if you don't use calculator, definitely if you don't use calculator, you are trying to find some easy thing to help you. So this one I can make it into 60, I can say 60 minus 4. And this one I can change it. So the first one I can say it's 60 minus 4. And I need to make this one something similar to this one with opposite sign. So I can say that is 60, sorry, this is a plus. That's minus 4. Since I have these exactly same, but the only difference in the sign, I can say 60 squared minus 4 squared. I know what is this. 3,600. I have to drop my zeros. And I know what is this. That is 16, which is easy. You can find it easily, which is just minus them. So, will give you immediately 3,584. So that is 3,008, 584. That's the idea. Let me do with you. Got it? Again, this one we can make it into, for example, 50 plus 2. That's for this one. This one we can make it 50 minus 2. These are same. This is same. This one same. But the only difference in the sign. So I'm going to use my rule. So that is 50 to the power 2 minus the second one to the power 2. So that is will be 2500 minus 4. You can easily minus it from this one, which is will be 2496. So that's the idea. Let me give you more exercises related, but not related to this one. I'm going to give you exercises related to the other things, which is here. Here is very important. That will summarize most of the lesson in one slide. So that is will really help you. Let's see this one. This one, if we are doing 36, so that is will be related to the first problem, the first key concept. So that is will be the first squared. The last one is squared, don't confuse, n to the power 2, then plus, since I have a plus here, plus 2 times the first times the second one, which is a 3n plus this one. Now that will be m to the power 2 plus 2 times the 3, 6 mn. Plus, here I have to put my parentheses. Now when I distribute the power, so that is will be 9n squared. Be careful if you have something similar. Not already directly basic, give you just x plus 6 and then ask you to apply the key concept, to apply the property that I just gave you. No, you might have something similar to this one. So just focus on that and prepare yourself for that. All right. What about 44? Please don't confuse between them. The first one exactly the same, the first term here. The second term exactly the same as the second term here. The sign is different. Since the sign is different, I can apply my rule, which is will tell you the first term squared minus the last term squared. So that is will be here, take this one, will be 16 x squared minus 49 y squared. Let me make with you more exercises, but I'm going to change the color. Remember, all these lessons are new for you, so you must practice them to make sure that you understand the idea. So I'm going to solve this one with you. Exactly the same idea. This one exactly the same as this one. This one exactly the same as this one, but the only difference is in the sign. So that is will be r to the power 2. Remember, please don't forget that this is all of it to the power 2. Minus 3s, all this to power 2. So that is r to the power 4 minus 9s to the power 2. That's the idea. Now I'm going to do also with you 43. I'm going to solve it here. So that is will be b 4 all this to the power 2 minus 9q2 all this to the power 2. I have mistake here. First number squared, the last number squared, minus, I have to keep a space, that should be at the end. So first term squared, the last term squared, so that is minus 2 times first, P4, times 9Q squared plus 9Q2, all this to power 2. So let's calculate this one. That's P to the power 8 minus 2 times 9, it's 18, P 4 Q2 plus, distribute your power here, so that is will be 81 Q to the power 4. So that's the idea. At the end of the class, I would like to give you a bonus question for the students that they watch my video until the last minute. So I would like to give you question. Simplify if you have A plus B plus C, all this squared. So that is bonus question. This is equals to what? Don't forget your homework. 8, 4 should be submitted tomorrow. Should be submitted Wednesday. 25 March. So that's the end of this lesson. Good luck, girls. Bye.